Welcome to part 2 of my test 2 review for statistics. Question number 4. I have the grade appeal process at a university requires that a jury be structured by selecting 5 individuals randomly from a pool of 10 students, 9 faculty. And we want the probability of selecting a jury of 3 students and 2 faculty. We want to round to 4 decimal places and interpret this solution. So this is the probability of choosing 3 students and 2 faculty. So using those combinations, we know that there are 10 students and we want to choose 3 of them. There are 9 faculty members and we want to choose 2 of them. And we want to multiply both of those numbers in the numerator, divided by a total of 19 people, and we want to choose 5 of them. All right. So tossing this expression into a calculator, or however which way you want to calculate it, 0.3715. If it helps, 10 choose 3 gives you a value of 120. 9 choose 2 gives 36. And 19 choose 5. That gives you a value of 11,628. So the interpretation of this is the probability of randomly choosing randomly choosing 3 students and 2 faculty for this jury is 0.3715. For question number 5, I have the table shows the movement of Walt Disney stock for 20 randomly selected trading days. Up means the stock price increased in value for the day. Down means the stock price decreased in value for the day. No change means the stock price closed at the same price it closed for the previous day. And I gave a table. Part A wants a probability model for the stock movement of Walt Disney stock, rounding to 4 decimals as necessary. So we need to build our table. So the values we have for this is that the stock went up, stock went down, or there was no change. The frequency. So if you count up all the ups in this table, that gives you a value of 10. If you counted all the downs, that's 9, and there's 1 with no change. And we need each associated probability and rounding to 4 decimals as necessary. So we are dividing each of these. The total number was 20. So you would divide each of these frequencies by 20. 10 divided by 20 is a half, or 0.5. 9 divided by 20 is 0.45. And 1 divided by 20, 0.05. Okay. So based on those numbers, part B has, is it unusual for the Walt Disney stock to not change in value for the day? Explain why or why not in terms of every 100 days. As you could see, it has a value here of 5%, right? And the cutoff that we had with regards to it being unusual for this class is indeed 5%. So 5% is not below 5%, right? So to answer, is it unusual? This would be a no. It is not unusual. For the stock, to not change in value for the day. And then out of every 100 days, we expect five, since 5% of 100 is 5. Expect 5 of the days there to be no change in the stock market price. So 5 days of no change. And additional to that, I've put C. Would the estimate of the probability of the Walt Disney stock price movement improve if we considered 190 randomly selected days instead? And then explain. The answer to that should definitely be a yes, right? But we need to explain that. So, since these probabilities form a probability model, from a probability experiment. Using the relative frequencies, which is what we did. Using the relative frequencies, the probabilities should change. To be closer or better approximated to the expected amount. Okay, question number 6. I have a contingency table, and a university conducted a survey of 360 undergraduate students regarding satisfaction with student government. The results of the survey are shown by class rank in this table. And if a survey participant is selected at random, what is the probability that he or she is not satisfied or is a freshman? You want to round to 3 decimals, interpret your solution, that type of thing. But just based on this table, we could tell this is not disjoint, right? You can be both a freshman and not be satisfied. So we have to use that general addition rule. So probability of not being satisfied or a freshman is the probability of not being satisfied plus the probability of being a freshman minus the probability of being both not satisfied and a freshman. So, there's a total of 360 in this table, right? For the not satisfied version, that total is here from the table to be 78. The number of freshmen is 91. And the number of not satisfied freshmen is 18. So for the numerator, we're doing 78. That's an 8. 78 plus 91 minus 18. That gives us a numerator of 151 divided by 360. Toss that into a calculator, you get 0.419. So the probability. The randomly selected student is not satisfied or a freshman is 0.419. Let me know if you have any questions or concerns. Thank you.